Hi, this is Dr. Taheri. Welcome to another SolidWorks screencast. Today we discussed about advanced sheet metal features including hem, jog, miter, and so on. Let's start with something again basic in sheet metal. First of all, you can activate a surface by right-clicking in the property manager and clicking on surface. We start with drawing a simple geometry. Go to front plane. We draw a simple circle with the radius of 50, and then we make a plane parallel to front plane. So let's go to the geometry and make a plane. One of the most fascinating features in SolidWorks is how easily you can create planes versus other software like Inventor. It's much more complex. So we go here, front plane, and I want to make the distance of 100. And I'm going to make actually 3 planes. Okay, these are the 3 planes here. So I go back to my initial plane and I modify the plane, so I will make a rectangular shape right here, and then I give a distance, a very small distance, so I give it 0.1 millimeter, and then I do a simple cut here. Okay, this is done. Oh, actually, yeah, this has to be done as well here. Let's just delete this one too. Okay, so I'm in the sketch here. I go to my next plane, and next plane, make a sketch on next plane, and then you select this circle offset, and I make it slightly bigger, maybe 20. Okay, looks like this. I go to my next plane, make another plane number 2, make another geometry on my next plane, and I again select my first circle offset, and this time I make it reverse 20, and finally I go to my third plane and I make a simple rectangular shape, and as a matter of fact I mention here to again 100, and this dimension here would be 50. Okay. So this is my geometry here, and we've got something here. So for this particular circle, the rectangular shape I have here, I have to do the same thing. I have to go here and I make a cut here by making a rectangular shape here and give a dimension of 0.1 millimeter, and we go to trim entity, this, and sort this. So the reason for doing this is when you want to use loft, so you cannot loft a closed geometry. So now I go to surface and then I use loft and I select my first geometry and my second profile 1 and then profile 2, and you can see this loft happens. So automatically selected these points and this point is connected to this point. This is good. I can continue with my next loft, which is another loft. So loft, and obviously in this case I select my second drawing, which is this drawing, and I loft it to the next one, which is this, and I have to make sure that the here has to go to here. Yes, I have to make sure that this corresponding lines are correct. So if I'm gonna select it here, so obviously the loft is not gonna work. So this is this edge, and so as the edge in here. So this is done, and then the next thing I would like to do, I want to do another loft, which is obviously, and for loft you can also use the points. So you can go and you can say loft, and I select this point, and I'll delete this. So delete that point as well as connecting it to the second one, which is to this point. And then this is here the next loft. So as you can see that this is extremely interesting feature. So you can create any geometry but keep continuing doing loft. SolidWorks gives you this capability of lofting geometries, and especially in sheet metal, that would be a very handy feature. At this stage, you can simply go also and you can use thickness, and you can use selecting as many parts as you want. So in this case, this part you have, and you can change perhaps the thickness to 2 millimeter. So it could be either or, depends on, it can be in the center here. And of course, in this particular case, if you want to make it desirable, you have to use the same for every other part, then to be consistent. You can have parts connected to each other with different thickness, if this is what you want. And here, I think there will be a problem because of the thickness. So it not matches here because of the geometry. So you have to be careful about that. Let me just change the thickness to 1 millimeter and see if this is working. In 1 millimeter it's not going to work, so let's see this one here. Yeah, so in this case it has to be very small because of the geometry, so that's the value of whatever it was. Okay, so this is one feature itself. Let's have a couple of other features, including I go here again and I make another drawing in SolidWorks. I go on right plane, and what I do simply I make some cuts here. Go from here to here to here to here, here. So shape like this, and then I make all of these to be equal value. So they all will be equal values. I can also define the equal angles here, but that would be sufficient here. And then I go on front plane, as a matter of fact, I should go on top plane in this case. So I go on top plane, and on top plane I make a circle, and again, doesn't matter what would be the radius, just give a diameter of 75. So here is done. I have shape like this. So the next thing I would like to do, I go and I do the same thing to cut the this circle, and for that I go and simply make a tiny rectangle, 0.1 again, that's the value here, and then I will go and in the sketch to trim entity, delete this, okay, so this is deleted here, and here also we have to delete this. Okay, this is done, and now the next thing I would like to do is I go to sweep surface, sweep surface, and then same as normal sweep, I select a path, a profile, and a path. So obviously you can see that this sweep has been done. Shape like this. So now, of course, I cannot unfold this shape because they are separate pieces. There is a very interesting feature in SolidWorks, and it's called Splat. Let me go here, and in this particular case, I go and I select the entire geometry, and I give the thickness of 1 millimeter right here to this. And what I would like to do is I would like to go and create a split. For doing that, first thing I will do, I will create a plane which is perpendicular, so it's actually parallel to right plane, and it is parallel to this face. So here is the plane, and just as a habit, because I want to draw something in this, I make it larger here. And what I'm going to do, I'm going to just go and draw some lines in this plane, and I try to follow these cuts. So these are the ones I have 1, 2, and then we continue doing it. So I apply from here to here, and then from here to here, and from here, and finally to make the final line, which is from here to here. Obviously, what I have here is shaped like this. Am I missing one? Yes, I'm missing one here. Then continue, and I make the last one, which is from this point all the way to this point. So this is done, and then I will go to insert feature split. So I've selected these lines, and then as soon as I press cut, it comes and create this cuts, and I can select them all. So these are the ones. So I have 7 pieces here. You don't need to change anything here, so just go and press OK. And what will happen is that you get all these 7 cuts here. So you require to save this, and I just go here, call it Splat test. This is my part. So I actually save the parts, and now what I want to do is I'm gonna go and I'm gonna save every single of them, and right click on the body, save bodies, and more interestingly, let me just select them all, and one by one we can save them, but before doing that, I go and I say browse, and I want to make an assembly. So in this case I call it test one assembly, which I have it here. So save that, and you can save every single pieces here, or just go here and save. It's in the review error, so let me just do it again, maybe because I saved it in the wrong name. So here, let's save each of them here, so one by one. So I save them and then save the next. So I have similar names here, maybe that was the reason causing a problem, and continue doing this. Okay, and then I go here and I want to save them as Splat 1 assembly. So I'm done here, and it goes and save everything one by one. It may take a couple of seconds, so it's saving it here one by one, and right away it creates actually an assembly of the same. And now here I can easily unfold my feature. Have few parts, takes a while, and I will say save and rebuild, and now I have it here. So aside from what I have here, so I can go to my window and I can see that I have an assembly, and this is the actual assembly I have. Now interestingly, I can simply create, insert a bend, and I can show one by one how it looks like. I go here to each part, edit parts. So you go to Sheetmetal and you go to insert bend, and this is this particular part here. And all I need to do, I want to create a bend here. I select this line, OK, and when I go to unfold or even flatten, so you can simply see that this is easily flattened without affecting the other ones. So this is actually an interesting feature in solidWorks. I created actually from one single part. I went and create 1, 2, 3, 4, 5, 6, 7 parts, and automatically solidWorks within itself, it did the assembly, all the mates, and it created. So this is another interesting feature actually we may have using Sheetmetal. Let's have some other features, and I can simply save or don't save that. I could have also simply go and change anything in my drawing. Maybe I can make the circle smaller, bigger, and it would have affected not only the part but continuously it reflect the change on all the assemblies and parts. Let's have another example. Just gonna go and make a simple square shape, 100 by 100, and I go to Sheetmetal and create a flange. Maybe 1 millimeter is good, so it's created 1 millimeter. And what I'm going to do here, I go to the surface and I want to make a simple sketch, which is a simple line connecting one of the diagonals. So, and then there is an interesting feature here which is called a sketch bend. So you select it, you go and select already this, and then you define what surface you want to have. This surface, and if I want to go and bend this, let's say 180 degree, and the result would be you have a simple cut like this. Let's continue doing that, and I want to make another drawings here, and in this case I want to make a cut. So from this corner to halfway this side here, this is done, and then again I go to Sheetmetal, so bend, and in this case I give 90 degree. So let's see what the problem here is. Then select the sketch. It could be because let's just change the angle to 45 and we'll see if it makes a difference. I'm still having an error. This error could be one of the reasons is the actual thickness, or maybe because the position actually is not correct. Let's go here and change its position here from this point, and we delete that and we bring it a little bit further here. That could solve the problem because this corner itself is not easy to bend. So we go select here, select this sketch, this bend 90 degree, and yet that was the reason actually, the position of that. So I cut this one here, and then I go do the same thing on the other side and making a sketch on this plane, and my sketch would be obviously from here again, from this corner, from a corner here all the way to halfway to the center, and this is going to be here. So this is done here, and then I go again to sketch, and here will be another one. You see, you can imagine what I'm going to make here. It seems like I'm making also paper airplane. So do a couple of more here, and that's it. So go ahead here, make another one. This is a good practice for doing this. So we go and make the sketch first. So again, I go to halfway here, and right away it tells you that you want to do the bend. So you select the face here, and in this case I go maybe again this for 90 degree, and you can do one here also. Do this and make a simple cut line. In this case here again, connecting half to halfway, done. Brings the proper window, and now you make the last cut. So this is again good practice, and then of course you can flatten this geometry. and the result would be you can create it without trying. So you can have it here, make all the cuts, and you know that you have to follow the cut. Other features here, maybe a few more features I'm going to go over. Let's have another interesting feature. Often students asking how do I, because they have a sheet metal, and my APSC 170 students, 71 students asking how do I make it, for example, tire or sheet metal. And that would be an interesting feature to make, but it's extremely simple. So I make a circle, let's make the diameter of 400, and then you go to sheet metal, make it as I go 5 millimeter the thickness, and then I go and I use hem, and you can see I simply make a geometry like this. So you can adjust, first of all, there are 4 options here. It could be like this, just completely flattened, or it can be a little different like here, or it could be completely up there. So I use this feature here, and you can see that by changing either of them, I can change the shape. So let's just stick with 40 here if I can. Actually 50 I think, or 60 is the minimum. And again, this cannot be changed as well. So that you can change the thickness of that. This is maybe 100. This is done. And what I'm going to do next is I go in this surface, make a drawing on this surface here, and I make a circle. And here is done. I'm going to simply go and do an extrude cut all the way over line. And here is done. So here's going to be my kind of tire. I can simply also go here to appearance, and I can use rubber, texture rubbers, tire. You can see how easily I made this motorcycle tire. One more interesting feature here. We get familiar with the feature of edge flange. So let's make go to top plane and make a simple rectangular shape, something like this. Convert that to sheet metal, which is here, and give a millimeter thickness for this. So if you want to make the flange, it's very easy. You go here and you can say in sheet metal, you go here edge flange. I can go and find. I can up to here. I can make a simple box out of it. And that's it. So you can unfold in this and flatten it. So this is very simple, but let's just not using that feature now, and I'm gonna go and delete all of them. This either. Okay, so the other feature that is interesting to use is called miter. So for miter, I go to this particular edge, I make a sketch on this edge, and as usual, normal to this. So this edge is here, and I start to making geometry like here. From here, I go to here, 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 and straight up here. So this is done. And then the next thing I do, I use miter, and I just move this here, yes, and I use this. In this particular case, yes, I should have made it a little bit bigger because now you won't be able to do that here. So then go to my sketch again, and I make some modification here. So I increase this, go a little further here. Maybe actually it would be easier in my sketch. I just simply go here and trim it to these pieces here. Okay, and I extend it here to this. This is very small. Okay, that's good, better. And then from here, continue from here, go here, here, depending on your angle, and here. That should be sufficient. So I use miter again, and I go and select this. And as soon as it's selected, it recognizes this side, and then I can actually go and add more into it. So I can select another one for this side, and it would add into it. So this is an interesting feature here again. So when you select it here, the size is very important here. I can do this side as well as this side. Which again here the problem I would say because of the geometry, so it may overlap. I could have actually increased the size and in my sketch here could have made it actually much larger. I'll just go back here and give it my fringe here in my sketch, and the dimensions are, I can make it larger, so I'll make it 400 by 400. Okay, and then unfortunately in this case here now I have to go and I have to delete this because now the plane is different here, and I make it a little bit more realistic here. I go to this plane, making a sketch in this plane, and I start to build my sketch from here, maybe go up to here, 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 and here. Okay, this is done, and then I go to miter, and automatically made it here. It should make it, for some reason it doesn't here. Let's see. It did one side here. It should do it all the sides here. It should not cause a problem when you do miter, but apparently here again, because of the thickness, I might have a problem. He did it correctly now. You have to really select this edge here, then just go back here and do it again. And sometimes it takes a little time for it to do it. And yes, that was the problem. So you have to be patient, especially if the computer is not that fast. So select this side, and then it takes time. Yes, it did that. So you can see that now we made this shape here. So interesting geometry, all done in one shot. And now if you want to actually change anything here, for example, if you want to go and then you want to change the miter, and there are quite a few here you have, you can change this shape you made here, and I can go and I can simply extend this longer, something like maybe this. and it would change the whole thing. And then obviously I can go here and I can make a similar shape on the top here and then do something like a pedestal. So in this case here I go to feature, I go to mirror and use mirror the body, which is the whole thing, and with respect to display. And here what we get. So here is a shape made out of sheet metal completely. Actually, you can see that here. The geometry also is kind of interesting. So this is another feature here. You can make as many as you want with the miter, different shape, different geometry. It will become very handy as well. Last but not least, I would like to show another feature here, which is called in sheet metal, it's called jog. So let me go to top plane and make another simple drawing. Just make a rectangular shape here. Obviously, I go and turn it to sheet metal. 1 millimeter is sufficient. And I go here on this plane and I make a drawing on this plane. I make another rectangular shape, just like this. And then I do an offset entity. Let's do one more. Right here, and selecting these lines here, and now I do an offset entity. I go reverse and I make it 2 millimeter, or maybe actually 1 millimeter is better. So here it looks like this. I do have to complete this here, and I go and connect this to this, and then do the same thing on the other side, and make a simple connection of this side to here. And I need to do a little bit of trimming as well. I trim this side, and that's it. So okay, and then I go here to feature, extrude cut. I want a simple extrude cut of this, and this is done. So obviously I made a cut here all the way through. You can see that here. The reason I did that because I need to make a feature is called jog. So for that, again I go and I make a drawing of this face, and my drawing will be let's say from here I go all the way to the other side here, straight line to here. So done this, and then I go to sheet metal and I use jog, and then you have to select the face, and it actually made the bend here, but the bend that direction is incorrect. So what it basically does, and it's way too much here. Okay, I want to do a simple. Let me just do one more time here. Basically, this is correct. So you have one. Let's go to miter again. Select the line, and then the gap is correct. Oh, I'm sorry. I had to go to jog and I forgot. So here, correct. We go here, and the fixed side is here. And now I'm not sure the fixed length I deselected, and something is wrong here. Why I did this? So usually when you do that, it should easily go and bring 20 millimeter up there. Let me just one final thing I would like to do. Let's just go and delete this and make one more drawing. Maybe the distance was not appropriate. We just go here and make a simple little distance from here and to here. Okay, so this is correct, both sides, and done the drawing. And then we go in jog, and then I select the fixed part, which is here, and it does the same thing. Ironically, I don't know why, it's very unusual. I never seen that before. It's very long for some strange reason. But if you would have done it correctly, you would have simply gone through it and we have created very simple geometry here. So it made a cut, but it did not actually do it. It's a very handy feature. One more thing I would like to try, and that would be perhaps the sheet and metal size. Maybe there is a problem with the thickness again. The majority of the problem with sheet metal is associated with the thickness, which is 4, and then we have it here. Let's go to this surface here. Okay, and that should be the other side here. Okay, that seems to be right. Let's go here to jog and select this, and here select, and ironically does the same thing. You are changing it, the angle. Oh yes, my God, this is the angle, 90 degree, and that's exactly what was missing here. So the angle is 90 degree, and you can see, and then what you do is you simply can change. Also you can see if the projection is the same, if you want to have the constant projection, or you want to have basically this length. So realistically, if you cut these things and bend it, you have not additional length. So that was the problem with the angle. So angle has to be 90 degree. You don't have to have 90 degree, but you can have any. And just to show you how easy is this, you can go and make another drawing another line here. You go make a sketch here, and then not necessarily when you need to have it straight. I can go from this side to this side, something like this, and then down again, and I go use a jog, and here is what I need, and you can see that make another one here, and I can maybe make the angle to be 45 degree, for example, and you can see that this has done it beautifully. So you can have it fixed, or in this case obviously it's going to be smaller. This is the same features as you have in Flex. So this is done, and you can see that you have a shape like this, so you can hang this one in some way. It's a very handy feature, and now that I did that, so I can go simply here and modify this line. So that wasn't the problem. So when I go to jog 1 here, this is the line I had, and I don't need to have the line. I maybe remove this here, move it to closer, as close as possible here, and you can see a jog would look a little actually better from there. I could have gone almost as close as possible to that particular side, which is being right there, and hopefully this is causing no problem. It actually does, because now it's too close, they cannot bend it. So you need to give it a little bit distance here. The distance should be enough that the bend is feasible. And let's see if it's do it again. So let's go a little further here. No, it doesn't want to do it either. It So again, this is a good feature here. I hope this helps in explaining several features that we can use in Sheetmetal, and it helps our students with Sheetmetal projects. Thank you very much.